Hi guys, welcome to lesson 16-4 on page 291, where we're going to be studying slopes of parallel and perpendicular lines. Now we already talked about these once a while back when you did the treasure hunt activity, but we're going to study them in earnest today and make sure we can use parallel and perpendicular slopes to write equations of lines. And then at the end, you're going to get a chance to prove, using this knowledge, prove whether quadrilaterals are parallelograms and even rectangles. So really pay attention and practice hard so that you're ready with any questions if you get stuck. It's fairly in-depth when you get to the end of the lesson, but it's you're going to feel very powerful when you can write equations with this information. So dig in there, make a big mess if you need to, ask me questions, and we'll take it from there. So we're going to be able to describe the relationships among the slopes of parallel lines and perpendicular lines, and then we're going to make sure we can still write an equation of a line that contains a given point, but that's parallel or perpendicular to a given line. So we're going to take some line they gave us, and then a point on another line, and be able to write the equation of a parallel or perpendicular line through that point. So let's see how it goes. Parallel lines and perpendicular lines are pairs of lines that have special relationships. Parallel lines in a plane are equidistant from each other at all points, so they never intersect. And you already knew that. So if we consider lines L1, L2, L3, and L4 on the graph above, or above on yours, to the left on mine, we're going to determine the slope of each line. So sometimes the easiest way to do that is to start at the y-intercept. So if I look at L1 and I'm reading from left to right, it looks like it goes up 1 over 2. So the rise over run for L1 would be up 1 over 2, or slope is 1/2. For L2, the slope, I guess I should say m equals for slope. M equals, so if we look at line 2 here, starts on the origin, also goes up 1 over 2, so 1 over 2. L3, the slope is, let's see, where's L3? Right here. So the y-intercept's on 0, goes down, let's see, here's another point. So it looks like it goes down 1, 2 over 1, 2, 3. Down 2, so negative 2 over 3. And then L4, the slope is, it should, let's see, here's the y-intercept, and here's another clean point right here, so it's going down 2 over 3, so negative 2 over 3. So taking slopes off of a graph, something you've done before, and then they tell us that in that graph, L1 is parallel to L2. So L1 is parallel to L2. There's the slopes we found for those. And L3 is parallel to L4. So L3 is parallel to L4. And there's the slopes we found for those guys. So we're supposed to write a conjecture about the slopes of parallel lines. Hopefully you can tell that the slopes of parallel lines are equal. They're the same. So determine the slope of a line that's parallel to the line whose equation is y equals negative 3x plus 4. Well, we have to assume that by now you know that's in slope-intercept form. So if it's solved for y, we know the slope is right here, the coefficient of x. So if a line was parallel to that, the slope would equal negative 3. Same slope as that line right there. But remember, you can only see the slope in an equation if that equation is solved for y. You can't see it in standard form or point slope form. Well, you can see it in point slope, but other random forms. Let's see. Write the equation of a line that's parallel to this, so we know it has to have same slope. So the slope here is 3/4. So we know that m is 3/4. And has a y-intercept of 0, 5. So b equals 5. If we write y equals mx plus b, we'd have y equals 3/4 x plus 5. So being able to write slope-intercept form and know that parallel means use the same slope. So here is the equation of a line that's parallel to this line, but goes through this point, this y-intercept right here. Horizontal lines are described by equations of the form y equals a number. For example, the equation of the x-axis, which is a horizontal line, right, is y equals 0, because all points on the x-axis have a y-coordinate of 0. So explain why any two horizontal lines are parallel. I would hope you're pausing this and doing it yourself and then listening, or you already tried it yourself. So you don't want to just write down whatever I say. That's not going to help you learn it at all. You won't remember that way. Well, hopefully you're thinking any two horizontal lines are parallel because they have the same slope, which is, do you remember the slope of a horizontal line? This horizontal line and this horizontal line, they all have a slope which is 0. Vertical lines are described by equations in the form x equals a number. For example, the equation of the y-axis is x equals 0. So here's the x-axis, here's the y-axis. So the y-axis, this one, its equation is x equals 0 because all points on the y-axis would have an x-coordinate of 0. This point might be 0, 5, 0, 4, 0, 3, 0, 2, 0, 1, 0, 0, 0, negative 1. All of those points on the y-axis, the x value is 0. Do you think that any two vertical lines are parallel? Yes. They all have, what kind of slope do vertical lines have? This one, and this one, and all vertical lines. They have undefined slope. But they all have it. So if it's the same, then they're parallel. So now we're going to use the information in 5 and 6 to write the equation of a line that's parallel to the x-axis. So let's remind ourselves, this y-axis, the equation of this line here was x equals 0. And it told us that the equation of the x-axis is y equals 0. So the x-axis here, its equation is y equals 0. Because anywhere on the x-axis, here, 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 maybe it's 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, negative 1, 0. They all have a y-coordinate of 0. So parallel to the x-axis would be something like this. So maybe it would be y equals a number. Maybe that number might be negative 4. So y equals, any number here would be fine, but negative 4 is the one I sort of drew. Any number. And parallel to the y-axis, which would be vertical, would be x equals, so parallel to the y-axis, like how about this one I drew here? Maybe that's 1, 2, 3. Maybe it's x equals 3. But it could be x equals any number. It just has to be a vertical line. So parallel to the x-axis would be a horizontal line, slope of 0. And parallel to the y-axis would be a vertical line with just an undefined slope. So horizontal lines, y equals a number. Vertical lines, x equals a number. Get that memorized for sure. It's going to help you save a lot of time when you know how to write the equations of vertical and horizontal lines. A customer of Patios by Madeline has requested a patio the shape of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. You know, opposite means across from each other. Parallel means have the same slope. Explain how you can use slope to check that the opposite sides of the patio design drawn in the coordinate plane are parallel. Well, opposite sides are parallel. So here and here, they should be parallel. And here, they should be parallel. So we want to make sure that they have the same slope. So these two here are rising 1, 2, 3 and running nowhere. So rise 3, run 0, which is undefined, right? Can't divide by 0. So both of these have the same slope. And so, therefore, these 3 dots mean therefore, they're parallel. Those opposite sides are parallel. On these green ones here, they're going down 1 over 1, 2, 3, 4. So down 1 over 4. In both cases, right? Down 1 over 1, 2, 3, 4. So that's, again, the same slope. Therefore, parallel. Opposite sides have the same slope, therefore a parallelogram. You just kind of proved it, and we're going to use that a lot second semester, being able to prove when we get to quadrilaterals if they're parallelograms by doing their slopes. All right. A line is parallel to this. Parallel means same slope. So parallel means same slope to this, and this would be the slope, right? Because this is in slope-intercept form, and passes through the point 1, 4. All right, so what's the slope of the line? The slope is 3. Explain how you know. Same slope as given line because it's parallel. They told us a line is parallel to that, so they have to have the same slope. Now write an equation of the line. Well, we know that the slope is 3, and we know, that it goes through the point 1, 4. So what kind of equation can we write when we know the slope on a point? Hopefully you're coming up with point-slope form, which would be y minus 4 equals 3 times x minus 1. If that's not second nature to you, if you can't just do that by heart, you want to ask for some practice sheets on that, and I can redirect you to the videos from Unit 2 to help you be able to write those. That has to be really, really basic foundation for you now that you can call upon it whenever you need it. So there's an equation of the line. Usually, when they don't say in a certain form, we usually go ahead and get it in slope-intercept form. So we'll go ahead and change that to 3x minus 3. We'll add 4 to both sides. So we'll have it as y equals 3x plus 1. Most often, when we're talking about linear equations, we'll put them in slope-intercept form. So we can see that this one's parallel to the starting one because they have the same slope, 3, and different y-intercepts. This one has a y-intercept of 1, and this one had a y-intercept of 2. So those lines are going to be parallel lines, which they were supposed to. All right, so now we're going to graph 4 lines here, it looks like. Lines 5, 6, and 7. So 3 lines. And then we're going to determine which lines appear to be perpendicular. Perpendicular means it forms right angles, and the symbol for perpendicular is this. So L5 has a slope of negative 4/3 and contains 0.02. So I'll put 0.2. Now this scale, you got to be careful about this scale. It's going by halves. So when I go down 4 over 3, I'll go down 1, 2, 3, 4 over 1, 2, 3. But even if I just went down 1, 2, 3, 4 over 1, 2, 3, it would still be on the same line, even though it only went by halves, because both of the scales are the same on the x and y axis. All right, so I'll connect those, and that'll be L5. And then L6 has 0, 0. and goes negative 3, 4. So down 3 over 4. Down 3 over 4. All right, up 3, 1, 2, 3, 1, 2, 3, 4. So connect those guys. Woo! Dropped my pen there. Didn't do too great, but I can move mine. It's a nice tool here. All right. Getting there. Close. We'll call that close enough. So that's L6. And then L7 contains the point negative 2, negative 1. It'll be right here. Because remember, it's going by halves. Negative 2, negative 1. And has a slope of 3/4. So up 1, 2, 3. I'm going wholes this time. So up 1, up 2, up 3. I could go halves. 1, 2, 3. Since the scales match, it'd be alright. It should be the same either way. 1, 2, 3 over 4. 1, 2, 3, 4. So that line's gonna look like this one. And that is L7. Now it asks us which ones appear to be perpendicular, and this is a little bit a matter of opinion because it's about which ones seem to be, which ones appear to be perpendicular. But remember they have to form right angles, so I think that 7 and 6 are not quite perpendicular, but this one, which is 5 and 7, that looks to me like a right angle right there. But this one, not quite. It looks a little bit too big to be a right angle. So I'm going to say that L5 is perpendicular to L7. And then write a conjecture about the slopes of perpendicular lines. So if we look at the slopes of those two lines, negative 4/3, positive 3/4, they are opposite reciprocals. So reciprocal means flipped over. Opposite means signs change. So L5 was a slope of negative 4/3. If we change the sign, it's going to be positive, and we flip it over, it's going to be 3/4. So those are perpendicular to each other. Opposite reciprocals. That is going to need to get memorized. Parallel means same slope. Perpendicular means slopes are opposite reciprocals. Check in with yourself. How you doing so far? Can you figure out the slope from a line? Can you graph an equation? Can you write an equation? And can you understand how you can tell and how you can create slopes that are parallel and perpendicular? We've covered a lot so far in this lesson. All right. Use our conjecture from the last one, which is that perpendicular slopes are opposite reciprocals, to write the equations of two lines that are perpendicular. And then on the grid, in the My Notes section, graph both lines and confirm that they're perpendicular. All right, so it says we can write any equations we want. Write the equations of two lines that are perpendicular. So let's make an easy one. Y equals, let's say, 2/3 x plus 1. If I wanted to make one perpendicular to that, I'd have to say y equals, I'd have to change the sign of this slope, right? Here's the slope, and flip it over. So we know it's going to be negative, and the reciprocal would be 3/2 x, and the y-intercept could be anything we want. It could be +1, could be not +1, anything we want. So we'll just make it +1. It could be, we'll just make it, let's see, I want to make sure it fits on my little graph here, so maybe I'll make it +3 just for heck of it. It could be anything. Mainly, in order to be perpendicular, we just need the slopes to be opposite reciprocals. Doesn't matter what the y-intercept is for those. So let's see. If we do the blue one, first out on 1, rising 2, running 3. Go the other way, fall 2, backward 3 to make a straight line. So that would be this line here. And then the red one in my here would be 1, 2, 3 for the y-intercept, and then it's going to fall 3 because the rise is negative, and run 2. So rise -3, 1, 2, 3, run 2. So that's here, 1, 2, 3, 1, 2. Go the other way, 2, 3, 1, 2. So that one would look like this, and we're going to see if they look like they're perpendicular. So yeah, looks like it. I mean, we don't have a protractor handy necessarily to measure that, but it does appear to be a 90-degree angle. So we don't want to assume when we're looking at geometric diagrams, but right now we're just sort of testing the reasonability of our conjecture. So in the coordinate plane, what is true about a line that is perpendicular to a horizontal line? Can you imagine that? What would be perpendicular? What would form 90 degrees with a horizontal line? Hopefully, you're coming up with a line that will look like this, right? Oops, well, it needs to actually be vertical. So in order to be perpendicular, you'd have a horizontal and a vertical line. So line that is perpendicular to horizontal would be vertical. So what you want to know is horizontal lines, horizontal and vertical lines are perpendicular to each other. That's really important to know. So if you see horizontal lines and vertical lines in a coordinate plane, you can say that they form a 90-degree angle, because that is a fact. Okay, that's a definition of vertical and horizontal. They form 90-degree angles because they are perpendicular lines. Their slopes are opposite reciprocals, but the slope of a horizontal line would be 0, and if you flip 0 over and change the sign, you'd have, because that's 0 over 1, right? You'd have negative 1 over 0, and this is undefined, and this is 0. So 0 and undefined are opposite reciprocals of each other. It's just hard to write an equation with the word undefined in it, so you have to know that vertical lines are x equals a number from the very, very first page of this lesson. Alright, line L1 contains the points 0, -1, and 3, -1. It is perpendicular to line L2 that contains the point -1, 2. Show how to find the slope of each line, then write the equation of each line. Alright, so one thing at a time. Show how to find the slope of each. Okay, L1, how do we find the slope from 2 points? You'll do y2 minus y1 over x2 minus x1. So 1 minus -1 for the y's over 3 minus 0. So that's 1 plus 1, which is 2 over 3. So there's the slope of L1. So m equals. Now line 2's slope would be, all we know is that it's perpendicular to this one. So it would be -3/2. Okay? Because it has to be perpendicular to that one. Flip it over, change the sign. Okay. Now it says then write the equation of each line. Alright, so line 2 goes through this point. Line 1 goes through these 2 points. Okay, now this one's a shortcut because that one's a y-intercept, and the way I know that is because x is 0, right? So I can just write y equals 2/3 x minus 1 because I have a y-intercept and I can just write slope-intercept form. This one, I didn't have 2 points to choose from, and I only have this 1 point, and it's not a y-intercept, so I'm going to have to build point-slope form. Y minus 2 equals -3/2 times x minus -1, which is plus 1. Distribute, because we're usually going to put these in slope-intercept form, remember. So we'd have -3 x over 2 minus 3 over 2. Now, when I go to add this 2 to both sides, if I don't want to add 2 to negative 3/2 and I freak out, I can clear fractions. They'll come back in the end, but I can clear them. So we'd have 2y minus 4 equals, gone, 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 negative 3x minus 3. Add 4 to both sides, just getting y by itself here. So 2y equals negative 3x plus 1. Divide everything by 2. So we'd end up with y equals negative 3/2 x plus 1/2. And you can probably tell if you had negative 3/2, that's negative 1/2. And if you added 2 to it, you'd get positive 1/2. So there's my two equations. If we look at them, this one has a y-intercept of negative 1 and rises 2, runs 3. This one crosses at a half, falls 3, and runs 2. Those are perpendicular lines. We can tell from their slopes that are opposite reciprocals. So there's a lot of, this goes, I did that real fast because all of that equation writing is why we worked so hard at it at the beginning of the year, because that's got to just be our background knowledge now so that we can go forward with proving our geometry concepts. Alright, let's see what we got here. Determine whether the lines are parallel, perpendicular, or neither. So, negative 4 and 1/4. Well, clearly they're not parallel. They're not the same. If I flipped over negative 4, that'd be negative 4 over 1, right? If I flipped it over, I would in fact get 1/4. And if I change the sign, now some kids get confused. They think this is a sign, negative 4, and this is a sign. There are not two signs in this fraction. This fraction is a negative number, so the opposite of it would be a positive number. It's a fraction, but it only has one sign to it, all right? We usually put the sign in the numerator. So negative 4 over 1 would be perpendicular to 1/4. So these, letter A is perpendicular. This one, negative 3 and 3, they're not reciprocal, so they can't be perpendicular. They're also not the same. Negative and positive are not the same, so this would be a neither. On letter C, 10/12 and negative 1 and 1/5. Well, we can't compare those. They look too different. So we could multiply bottom times side plus top here, and we get 5, 6. So we have negative 6 over 5. And if I reduce this, I would have 5 over 6, right, for reduced. So if I look at this, negative 5 over 6, negative 6 over 5. Oops, that's not a negative, that's equals. So 5 over 6 and negative 6 over 5. Look at those. They're opposite signs and reciprocal. So those are perpendicular. So this one was perpendicular. This one was perpendicular. And then here on letter D, we can easily see 1/2 and 1/2 are the same. So those are parallel. That means parallel. And these mean perpendicular. All right, write the equation of line, or the equation of line L1 is y equals 1/3 x minus 2. Write the equation of a line parallel to that. Explain. So explain would be same slope. So parallel could be anything with the same slope, but it couldn't have negative 2 for the y-intercept, or it would be the exact same line. So y equals 1/3 x, and then anything besides negative 2 here would be fine. Or even a 0, nothing there would be fine. I'll put plus 1. I like plus 1. All right, write the equation of a line perpendicular to L1. Well, we just have to take this slope. To be perpendicular, we have to take this slope, reciprocate it, flip it over, and change the sign. So explanation is slope is opposite reciprocal. So y equals, flip it over, that would be 3, but we got to change the sign, so negative 3x. And it could have, and it doesn't matter. The y-intercept can be anything because it's already got a different slope. Right, so you could have plus 1 or minus 7 million, whatever your favorite number is there for the y-intercept. Write the equation of a line that's parallel to 3x plus 4y equals 4 and contains this point. So we know we're going to have to write point slope form, but first we got to figure out what our slope is. So you can't just say the slope's 3, because as this little hint here said, first you got to solve for y to see the slope. So we have to get y by itself before we can even see what the slope is. So we'd have 4y equals negative 3x plus 4, and then we're going to divide by 4 to everything. So we got y equals negative 3/4 x plus 1. Now we can see the slope. Okay, there's the slope. And we're supposed to be parallel to that, so same slope, right? Same slope through this point. So point slope form would be y minus 1 equals negative 3/4 times x minus 8. That's point slope form. I'm just going to leave it in point slope form right now because I don't have a lot of, well, you can, it would be, if I distributed, this would be 24 over 4, which would be 6 plus 1. So the final version would look like y equals negative 3/4 x. That'd be plus 6 or 7 plus 7. You can be doing these on separate paper where you have a little bit more room, and just make sure it turned out like that after you distributed and added your 1 to both sides. Write an equation of a line that's perpendicular to this line. Okay, so there's the slope, but we need perpendicular. So perpendicular would equal, flip it over, so 1/5, and change the sign. So flip it over 1/5 and change the sign. It was positive, so we'll have negative 1/5. And it contains this point. So we would have y minus 2 equals negative 1/5 times x minus negative 10, which means plus, right? Distributing. So y minus 2 equals negative 1x over 5 minus 10 over 5, so that would be negative 2. Then we add 2 to both sides, so we get y equals negative 1/5 x period, plus nothing, plus 0. It's canceled out also. So that's a lot of equation writing. And if you're working with a tutor, or if you're working at a little bit slower pace, you need to make sure you take these problems, forget about everything you wrote because you may not understand it. Get a piece of loose leaf paper and try it a little more slowly, and make sure you're honest with yourself about what you can do, what you need to practice more. Let me know if you need help or more practice, okay? Alright, let's start this off here. Determine whether the lines with given slopes are parallel, perpendicular, or neither. So these are not parallel because they're not the same. But are they perpendicular? No, because one of them would have to be negative. So this is a neither. How about these two? Negative 6 and 1/6. Flip it over, change the sign. That's perpendicular. These two, exactly the same. That is parallel. Alright, the slopes of 3 lines are given below. Determine the slope of a line that's parallel to a line with each given slope. So M1 would be the same slope, so negative 1/2. And slope 2 would be 3. Slope 3 would be 0. Parallel means the same. Now perpendicular, M1 would be, change the sign, so it's going to turn positive, and flip it over, 2. Change the sign, negative, and flip it over. So it's going to have to be negative. And what does it look like if you flip over a 3? 1/3. Okay, so you got to make sure you're getting the signs. And the slope, the third slope, if I flip over 0, I explained this a couple pages ago. What is the opposite reciprocal of 0? Undefined. Okay, Determine the slope of any line that's parallel to the line described by this. Well, if it says y equals, we can see the slope. So parallel means the same, so slope would equal -1/2. Parallel slopes are equal. Alright, write the equation of a line that's parallel to the line described by this. Okay, so describe how you know they're parallel. We need the same slope, okay, but we can't tell this slope until we get y by itself. So x minus 4y equals 8. Let's get rid of that x. So -4y equals -x plus 8. Dividing everything by -4, this gives us y equals positive, negative is positive 1/4 x, and then -2. So here's the slope. Parallel would be same slope, so the answer would be, it says write the equation of a line, equation of a line. Alright, so anything I want, y equals 1/4 x, as long as I use a different y-intercept than -2. Could be anything you want. We'll say +5 just for fun. Okay. Coordinates for the vertices of a quadrilateral are given. So you're going to need to, create a little graph over in your margin or on graph paper, which should be in your binder. And then you can insert it, put the page number where the problem comes from, put it in your binder right behind this page of the book. Determine whether each figure is a parallelogram. Okay, so vertices at, this is going to be my letter A, 2, 1, 4, 3, 2, 4, and 3, 6. So here's my parallelogram, perhaps. We're going to test it out. And we can, in order to be, if you remember the definition of a parallelogram, opposite sides parallel. So if I look at these sides here, one's vertical, one's not. So no, opposite sides are not parallel. That's why it's not a parallelogram. That's how I'm explaining my reasoning. Even if this other side was, but it's not, 2/1 and 2/2. So even if one pair of sides was parallel, if the other pair isn't, then it's not a parallelogram. So let's check letter B. -2, 1, -2, -2, and 1, 4, and 1, 1. So there we go. Alright, so we've got two verticals. That's easy to tell that they're parallel. And then we'll just count the slopes here to make sure. So we've got up 1, 2, 3 over 1, 2, 3. So the slope is 3/3, which equals 1. And on this side, it's up 1, 2, 3 over 1, 2, 3. So this side and this side both had a slope of 3/3, which equaled 1. So yes, opposite sides have equal slope, so they are parallel. Therefore, parallelogram. The parallelogram, if both pairs of opposite sides, maybe we should write that here, both pairs, opposite sides parallel. Alright, so you're going to try these. You know where the key is on JT Learning. You're going to try these, especially pay attention to number 27. They tell you a rectangle is a parallelogram, so you know that opposite sides have to be parallel, with 4 right angles. Okay? So in order to form 4 right angles, adjacent sides would have to be perpendicular, right? So if I had sides like on a graph, you'd have to make sure that this side and this side were opposite reciprocals. They'd have to be perpendicular adjacent sides. Opposite sides would have to be parallel, but adjacent sides would have to be perpendicular slopes. You'd have to check the slopes to see. So there's a lot of checking in number 27 and explaining yourself. Okay. All right, see what you can do. Make good use of the key and really find any trouble spots and see if you can build your knowledge little by little before you get graded on it.